Hey everyone, welcome to this explainer. I'm so glad you're here today because we are jumping right into something that pretty much every programmer wrestles with, writing beautiful, readable code. Specifically, we're geeking out over Haskell syntax today, pulling directly from some brilliant notes and published back on May 9th, 2026. We're going to see firsthand how finding the exact right balance between logic and data can absolutely transform a piece of code.
So, can a single character really change how you think about code? I know it sounds like a massive, maybe even exaggerated claim, right? But honestly, by the end of our time together, I'm pretty sure you're going to agree the answer is a resounding yes. Okay, let's dive into this and kick off our quest to cure clunky code.
Which brings us to Section 1, the quest for elegance. Now, every good quest needs a villain, right? And in our story today, the big bad is deeply nested parentheses. Just take a look at this original line of code from our source. I mean, yikes. Look at the end of that line. 1, 2, 3 closing parentheses, all just stacked up on top of each other. It literally forces your brain to work backwards from the inside out just to figure out what belongs to what. This is exactly the kind of mess we want to clean up.
Moving right along, Section 2, the step-by-step evolution.
Because we absolutely aren't stuck with that visual nightmare, we're going to go on a bit of a Goldilocks journey here, refactoring this code step by step to find what's just right. Here's the roadmap of our evolution. We start at stage 1 with those messy parentheses. Stage 2 tries cleaning it up using just the $ operator. Stage 3 mixes it up, using both the dot composition operator and the $. But Eng actually noted that this mixed version felt, well, kind of like alphabet soup. So, driven by the desire for ultimate cleanliness, they pushed forward all the way to stage 4, exclusively using the dot operator. Let's see what happens when we hit that final, quote-unquote, pure stage.
And here we are at Section 3, the point-free trap.
You know, sometimes in our pursuit of perfectly elegant code, we can actually push a refactoring a little too far. Now, what's really interesting about this slide is, sure, we successfully chained everything together using only the dot operator. But look closely at the very beginning and the very end of that function chain. We actually had to wrap the entire chain in parentheses before we could apply it to our string unsupported format. So our earnest attempt to escape parentheses literally led us right back into them. No way around it.
Real quick, before we fix this, let's clarify some jargon. The expression inside those new parentheses is written in what's known as point-free style. And don't let the name trip you up. Point-free actually has nothing to do with the literal dot operator itself. It simply refers to a chain of composed functions that hasn't been given a distinct declared name.
Now, this point-free style relies super heavily on a concept called partial application. Basically, partial application means we're referencing these functions and linking them all up without actually passing their final arguments just yet. It is a wildly powerful tool, for sure. But, as we just saw, relying exclusively on it for this specific line of code, it forced us right back into the exact trap we were trying to escape.
Okay, Section 4, separating logic and data.
So if pure point-free style isn't our ultimate savior here, what is? Well, the author discovered that reverting slightly back to stage 3, mixing the dot and the $ operators, is actually the idiomatic accepted way to write this in Haskell. And the reasoning behind this is just brilliant. I absolutely love this quote, straight from Eng's notes. We use the $ operator to create a clear boundary between the logic and the data. So the crucial point is that we are no longer just arbitrarily chaining operators, we're actually using syntax to structurally separate what the code is doing from what it's doing it to.
Let's break this down to really anchor the concept. Over on the left side, we have our logic, pure.left.pan.error. The dot operator is basically acting as our glue, smoothly chaining all our logic steps together into a single, seamless pipeline. Then, bam, we hit that boundary, the $. The definitive visual signal immediately tells the reader, okay, the logic pipeline is done, and the actual data, packing our unsupported format string, is about to begin over on the right.
Let's look at the ultimate before and after. On top, we have our clunky, nested nightmare. On the bottom, our final, beautifully idiomatic Haskell code. And this brilliantly illustrates our Goldilocks solution. By combining the dot and the $, we hit the absolute sweet spot. We've stripped out all those unnecessary parentheses, and we've actually increased the clarity of the code by clearly dividing the action from the subject. It's a real game changer.
Which takes us to Section 5, the mathematical connection.
Now, for those of you who really love the theory, the elegance of this solution goes even deeper. There's this beautiful parallel here that bridges the gap between our everyday programming syntax and formal, high school-level mathematics. If we take our clean Haskell code and translate it into a formal mathematical expression, it looks exactly like this. Just look at that notation. You've got the composed functions grouped together, operating on the input p of x. It looks elegant, it looks formal, and it probably looks incredibly familiar if you've ever studied function composition in algebra.
Let's move to this and see how this builds directly from our code. Our mathematical u is the pure function, the unit function in monads. L is left, E is our pandoc app error, and P is pack. And finally, X is our input string, the raw data itself. Those dot operators in our code literally represent that little circle composition symbol you see in math. It is a perfect one-to-one mapping.
It really just all ties together so perfectly. Which brings us to our final thought, taken directly from the source material. Isn't it fascinating how a small syntactic shift changes our mindset about code? Think about it. We didn't change what the program fundamentally does. We just swapped around a couple of characters. But by doing so, we shifted our entire mental model from nested operations to a clean, logical pipeline operating on distinct data. So thank you so much for joining me on this explainer. I really hope this leaves you inspired to look at the boundaries in your own code differently next time you sit down to write.